Well, good evening. It's time for a new project. This new project tonight, we're going to install a residential refrigerator in our RV. I've done quite a bit of research, and the reason I got onto this, a friend of ours down in at a campground we go to down in Florida, recently his RV nearly burnt to the ground because of a faulty refrigerator. His fire was due to a Norcold 1200. And if you do a little research, in fact, I'll put a link to a video where I did some research on what's causing these fires. And I thought, well, to avoid that, I'm just going to replace our refrigerator. It's already 18 years old anyway, and I want more storage. I've already got 300 amp hours of battery. I got some solar panels. The low wattage use, this particular model, this is a higher 9.8 cubic foot. It only draws, my testing was showing it's running about 82 watts of power. Their specs says it pulls between 70 to 120 watts. The maximum, I guess, when you go into defrost mode, you probably pull 120 watts then every few days when it goes into defrost. But I was just wanting to point out, like here, here's at Lowe's, and there's the item number 970843. There's the model number. That's the black version. You can get it in black, white, or stainless steel. But the biggest thing is checking out the reviews. That's what I was going by. So if you go by the reviews and put in the word RV, you'll get like 161 people have reviewed this, and you see about all of them have 5 stars, and they have pictures of their installs. But you know, I watched some videos, but I didn't see any really detailed videos on doing an install. So I've done I think a fairly detailed view from start to finish, and doing all my testing. Also, you can even buy it at Best Buy. They have them also. Seem to be a little bit more, but still, you can still read the reviews there. And even at higher appliances, they have reviews here. So there's several places you can do your own research on this particular model. One thing I stopped on this picture, I found this interesting because I'm hoping a lot of you, I can convince a lot of you who have the 1200 series refrigerator to get those upgraded to a residential to avoid any future fires. It just seems to be so common. But I like how this fella did this. I don't know who it is. He just posted a picture, but you can see he used to have a 1200 series there. That's how large the opening is, and he just used the old trim that went around the 1200 and left it, put it back on, and put a little shelf in. So I kind of like how he did that. There's another picture. So that might give you an idea of things you could do to, even though, you know, a 1200 series I assume is around 12 cubic feet. Where these are 9.8 cubic feet. So you can lose just a little bit of storage, but you're going to gain peace of mind on that. So I think that's a good trade-off. See, here's a picture of a fellow who bought a stainless steel model, put it in his RV. And let's see what else we got here. Okay, here's one that's similar to how our RV is laid out. You can see how much stuff you can put in there. You can see how it fits right in there, really nice and clean. This I don't like. I don't know what they've done here. It takes away from it. Whatever these brackets they've used to install, I don't like that so much. You'll see with my install, I don't have that. But it is an awesome fridge. And at the time of making this video, I paid $449 for ours from Lowe's, had it delivered, even free delivery. I printed this out here. I was reading on some reviews and where people ask questions and the manufacturer responds. And this question was asking about the wattage used and the amp draw. If you're into amps, you know, 0.7 amps up to 1.2 amp draw. And then wattage would be 70 to 120. That was from another interesting article I came across, a question that was answered. And it says, does installing this refrigerator in a travel trailer void the warranty? And the response from the manufacturer says, as long as it's installed to do the specifications, you will still have a warranty on it, even though it's installed in an RV or travel trailer. So that's good to know. But anyway, sit back and enjoy the show. I think this is going to make for a great upgrade. See you later. Welcome back, my YouTube friends. Guess what today is? Today is Get Rid of Your Norcold Refrigerator Day. So I'm finally going to get started on this little project. I'm taking out this gas absorption Norcold refrigerator and going to replace it with a residential refrigerator. A couple of reasons. One reason is this thing's 18 years old, and you know, I never have really cold ice cream on hot days. But the biggest thing is there's always that risk of fire. Not so much with these small refrigerators like this, but the 1200 series. If you happen to have a 1200 series Norcold, do some research and watch the previous video I did on about the Norcold fires, and maybe you will come to the same conclusion I did. Let's get a residential fridge. The one I've chosen to put in our RV is going to fit right in this hole. I do believe. I'm about to find that out, and so follow along with me. We'll figure this out. I did take this thing out about 8 years ago when I put in my solar. I can't remember how I did it. I do remember I had to get up on the roof because there was a screw on the back side. The only way to access it was to get on top of the roof, take the vent cover off, and go. I think I cut the screen out to get down in there, take the screw out, and then put the screen back and all that stuff. And then when I put it back together, I left the screw up. I opted to leave that screw out because I knew I'd be back into it later, and so I shouldn't have to deal with that. But if you're in a Winnebago and you take all these screws out, I can't remember how many there are, and they don't want to come out, you may have a screw in the top that you have to go through the top vent through. So I know I got a couple screws up here to pop out. So get these little plastic covers off. There you go. I know I got 2 up here to remove, and I'm going to have 2 at the bottom. And then I'll get those out and get started, and I'll just keep making little snips of videos as I go along. All right, first step, we take 2 screws out the top. That wasn't no problem. There we go. Get that trim piece off. Now at the bottom here, I had 2 screws in it on this plastic trim, which you take those 2 off, 1 in each corner, remove that. Then you got 2 more screws that's hidden. So I'm gonna take those 2 out and then see what that leads to. All right, now that's everything that's obvious. And now I'm going to go on the other side and take some bolts loose on it, and also, of course, remove the gas line. Okay, so I guess the next step will probably be wise to turn off the gas supply. All right. Now we got the now here, when you remove your gas line, you want to make sure you support the valve. You see I got this wrench here and that one there. So you get it. When you do that, because you should use both hands, but then you can break it free. I already broke it free a little bit just to give you the idea of what you want to do, so you don't stress out these components bending anything. There you go. You better look. So I've got that loose. Got no smell of propane, because it really stinks. Got that. Right, we've got our 12-volt wires we need to unplug. And I did mark it here. You can see yellow and white. In fact, I did that, I guess, years ago. So I know I can put it back in the same spot. Not that I ever plan on going back with it. But if I want to power this up in the future in the garage or something other, I'll know what I need to do. Got that. Now we got some bolts in there. We got looks like a 9/16. I think we got 4 of those to take loose. I already got the 110 unplugged. So let's get those 9/16 bolts loose and see if that see what happens. All right, so I got those 4 screws out, and it looks like I need to take that loose because I noticed. So it looks like this plate here stays with the fridge. Maybe this part stays with the RV. And they got these screws going right kind of into that. So let's take that loose. All right, bottom one out. Looky there, looky there. All right, do you see anything else? I don't see anything yet. Let's go do a little wiggling. Well, as you can see, that's all it took. Just taking a couple of screws out, and but it is tight in there. So I'm kind of wiggling it, just a little at a time. Grab one corner, grab the other, and just keep working it out. Little by little, I'll eventually get it. But that makes for some boring video. So So I think I got to get a strategy. I want to get that sit on. You can see I'm out of breath, huffing and puffing. So let me stop and think. All right, so here's my solution. I got this little step stool of a thing had sitting around. It's just about right. It's just a little bit low, but I'm going to slowly wiggle it out a little bit more till it tilts down and starts resting on it. And then I'll see about how go about getting it out of the RV. That'll be fun. Of course, keep in mind I'm doing this by myself. I may have to holler for Sweet Pea here in a minute. There it is, almost out. And I've been only on this about 30 minutes. It's really not that big of a deal. So I'm just ease it out just a little bit more, kind of get it balanced. Because I figure there's probably more weight on the hind end. So I'll have to be careful as it comes out and make sure it stays sturdy. All right, easy peasy, it's out by myself. And you can see it's balanced right here. So that wasn't so bad at all. And I get to get in there and see what kind of goodies I'm going to get into as far as mounting the new one in there. Projects. I just love my projects. All right, you see she's all scooted out of the way. That worked out real easy. You know, if I came in at 143 pounds this morning, so if I can do it by myself, so can you. Got that done, and so now here is our hole. Now we got to do some thinking and get a plan. First of all, I do realize we got to get rid of these baffling the seal. Of course, with gas absorption refrigerator, you need this because you need to create that chimney effect, so it seals against the box, and so the chimney effect is always keeping that heat coming up and going up through the roof vent. There it is, a roof vent full of pine needles. Oh, and there's that metal plate I told you about. If you can't get your refrigerator out, these screws may be anchored into the top of the refrigerator. You have to get access through the roof to get them loose. I'll be getting rid of these baffles. I don't need those. There's one down there, and because this is just held in with staples, that's no problem. And remember, from the manual on the new refrigerator, yeah, of course, if you didn't see that first video I made where I was doing the testing of it to see its amp draw and everything, it doesn't have any external condenser coils, which is great because they don't get dirty. You don't have to clean them or anything out. So, but it gets rid of its heat through the sides. It'd be like right here. If you touch it, you feel it gets real warm. And per the manual, they want at least a 1-inch air gap on both sides, which that won't be a problem. But if I left these in place, that would be a problem. So I want to get that out of the way. And I did, if I wanted to, I'm thinking about it. I could add a vent right here, just a grill so it wouldn't look like a white grill. Actually, you know, something like that, but smaller. I could do that, and that would allow air to flow through and help take the heat out. Don't know if that'd be necessary or not, because we're going to have this big opening in the bottom that's going to have that chimney effect. But I could monitor the temperatures in the future. If I see it's getting warm in there, I could always put a grill in that. So, all right, I guess I need to muscle this thing out of here. So I'm going to have to get these plates off. Maybe give me some more working room. Get the new fridge in here and take some of this stuff apart. It looks like fun. I wish you was here. Yeah, now I know I'm pushing it, but I'm doing this by myself. I had to figure out a way how to get this onto the floor off of that little stoop and not tear anything up. So I've laid it down on this. It's kind of balanced. And I'm going to slowly scoot it toward the floor. And then I can stand it back up. If I do it properly, I won't tear up Sweet Pea's floor. All right. I'm okay. Tilt it up. There we go. Ta-da. That wasn't so bad. Now just get me a little hand truck on this thing and get it down those steps. Yeah, that'll be fun. Okay, now here's the plan. So I got the hand truck strapped to the refrigerator, and I had to, if the steps are out, I won't be able to, it's going to cause issues because I'm running out of space. So I got me a little magnet to trick the steps to stay enclosed, and I'm hoping I can just ease it down these steps to the concrete without hurting it or me. So that's the plan, and wish me luck. Yep, I got it out, but it was a little bit scary. I got to the end, and this carpet, I had my feet on the carpet, started sliding with me. But we got it out okay without. But yeah, I would advise having help. Don't do that by yourself like I did. So I just got to get that turned around, and now get the new refrigerator in here. Don't tell Sweet Pea what I just did. She'll kick my butt. All right, we're about ready to hoist the new refrigerator in here. I got some help on the way because I can't do this one by myself. Well, you see, we got it in there, but I wanted to tell you a quick funny. Because you know I got this out by myself. It wasn't easy, but it wasn't smart, but I did it. And so I got my Sweet Pea to help me put the new refrigerator on the dolly and bring it in the building. Now as we opened up the door, she came in, she saw this sitting here, and she said, "How did you get that out?" And I said, "I had help." Well, she said, "Well, who helped you?" I said, "Jesus." She said, "You're going to need Jesus if I catch you doing that again." So I thought that was funny, bless her heart. She didn't want me to hurt myself. But anyway, got that part done. And now I'm getting things gutted out. Got all those old plastic strips out of here. And I'm kind of going to do a dry run. Just going to tuck that thing. I got this, I'm going to try to get hoisted up on this board by myself. And I got on this carpet, so it should slide pretty easy. So I can slide it up here, get it in. And I kind of done some measuring. You can see how these wheels are. The wheels, see, they're just a little bit below flush with this. So I think it'll roll. And it should be, the way this board is lined out, the wheels should just drop off the back. And at that time, the refrigerator should be resting on this bar all the way across. I kind of like that. But I don't know that I like the fact of it just resting on these little legs here. I'm just going to do a dry run, and I got to get a plan of a good anchoring system. So I'm just going to poke it in there and see what it looks like. So let's get to that. Well, there you go. Got that up there by myself. It looks a little precarious, doesn't it? But it's fairly easy to move because I got that carpet under there. So just give it a push and line it right up here with the opening. Because I'm gonna need two hands here shortly. There we go. Let's see if I can't wiggle it up in there and do it first dry run and see what it looks like. All right, so just so you know, attempt number one was a failure. These are making it kind of snug. So I'm gonna pop these little pieces off here so it doesn't fight me as it goes in that opening. So let me get those popped off, remove those staples, and we'll try it again. I don't know. What do you think? I think that's gonna look pretty dang good. That really fit just perfect. Couldn't ask for, I didn't have to shave off any wood at all, but look how snug. Just, you got maybe 1/8 of an inch on each side, but that's all you need. I got a little bit of wiggle room. I'm still strategizing on how I'm going to anchor it. I got a loose ideal. Thinking about, because I got some strong anchor points on each corner. You see them up there. That's where the hinges mount. And I'll use those strong anchor points and get me some nicer aluminum angle metal and spray it like a flat black. Maybe get me some stainless steel button head screws, something other. I'm still working on that ideal. And then I can kind of do the same on the bottom too and put a good strong anchor on that. Let me show you on the other side what it looks like. Turned out really nice because I got it flush, and you see I got space back here, and I have to scoot over my receptacle just a little bit. I relocated my wires from my solar system, pulled them back a little bit farther, but and you can see how the wheels, I told you the wheels would clear. They're not touching now. And this metal piece, this indentation, that is resting all the way across that white piece, if you remembered looking in there before. So the way the refrigerator is being supported all the way across the bottom, I like that. Not just on the wheels or something. So I like how that's working. We got a gap going all the way up through there so our air can circulate. You know, we got, see the spacing, we see we needed, what did it say? We want 1 inch spacing on the sides, which we got. That's not a problem. Got 1 inch on both sides, and we got, you know, more than 2 inches on the top, like the book says. And even got some space underneath here. So that's gonna work pretty smooth. So, all right, on to the strategizing about anchoring this thing in. In fact, I don't think I'm going to pull it back out. I thought I was just going to have to do a dry run and then maybe pull it back out and make my modifications, but I believe I can do everything I need. I can just scoot it out a few inches, make my modifications, and anchor it back in place. But so far, I'm liking it really well. Look at all that space we're going to have for food. Instead of, what was it, 7.9 cubic feet, now we're about 10 cubic feet. And we're going to have nice cold 0-degree ice cream. It's got an automatic defrost. We have no more frost to deal with. It's going to be great. Can't wait. Okay, now I'm in the planning stages of how I'm going to anchor this thing really securely to the RV. So here's what I'm thinking about. I got this pretty nice aluminum angle. And I got these really strong mounting points from the factory where you mount the door hinges. But the problem is I need to transfer this odd pattern to this piece of aluminum. So I've got me a piece of plastic here. This is actually from it's a piece of vertical blind, just thin plastic. So it's worked out well to create a template. You see I've already punched one hole back here, and I've already made an indentation. So that lines up with that hole, and I'll punch that out. Then I can transfer that pattern onto this, and I won't have, hopefully I won't have any slop. The bolts will line up nice and clean and make for a nice mounting bracket. Okay, another close-up picture of how I'm transferring this over. See how I've done this? I just get the sharp point of the awl and start pushing around. You can feel the soft point. And just shove it down through. It's got it lined up really good. So I know my bolts will line up and make me for a nice pattern. That's how I did that. All right, I'm doing some fine tuning here. I wanted to point out something. I don't like the idea of having this much weight on these little plastic wheels, because I've got rental property and I'm all the time coming across these wheels that get cracked and broken. You can get a lot of weight on those little plastic wheels. I don't trust it, especially in an RV. It may be all right, but I want to make sure everything is sturdy as we're going down the road. So as I roll this back, the wheels drop over the edge. As soon as they drop over the edge, you can see this recessed area back in here. Well, that goes all the way across. You can look down from underneath. There it is. So it's about a 1 inch. It drops down about 1 inch, and it's about 1 inch wide. So that piece of metal, excuse me here, will be resting all the way across here. So the weight will be on it. So I wanted to do the same on the front. So let me show you what I've done there. So I got me 2 pieces of plywood here that I cut. I'm assuming it's like 2 pieces of 1/2 inch. It comes in just a little under 1 inch here. You can see it's just slightly under 1 inch. And you can see I've got some brackets on here I'm manipulating and testing with. I think it's going to work out pretty good for me. But I want to make sure we have a good support all the way across the bottom. So those little pieces of plywood I've cut them, I think about 23 inches by 3 inches wide. So it'll be resting on the edge, because that's where the most strength is, and go all the way across to the other side. So I like that ideal better, instead of supporting all the weight on these 2 little plastic feet that comes with the refrigerator. I don't like that ideal at all. Not for driving down the road with as much weight as you can pack in one of these things, because that thing will hold quite a bit of food. So let me put these boards up in here and I'll show you what it looks like. Okay, you see I got them in position now. And I'll just push the fridge back in there and let it rest on them. And so that way the fridge will be very well supported and won't be going anywhere, especially after I get these plates here finished. And I'll put me some screws in it and anchor it right into the wall here. So I'll get on to that. Okay, some of the most time-consuming thing I've dealt with is getting these holes to line up exactly right. That's how my bracket is. But I got to make allowance for the hinge. I got to get some little spacing going on, because I got to get this hinge back under here and space it up, and do the same on this side. Because you can see how I did it down here. I got me some longer bolts actually. Got me some 6mm by something. What are they? Yeah, 6 by 1 by 25mm. So that way it made it longer, so I could go up through the plate, the hinge, and then into the refrigerator and give it a good strong support. Then on this side, I put in a stack of washers to get my spacing correct. And I got to do the similar thing up above. Then after I get it all, once I decide exactly what I'm going to do, everything's pre-drilled, then I'll take it all off, paint it, then put it all back together. Yay! I was going to point out to you again, making this template really worked out well for getting my holes to line up, because then I was able to just line it up flush with the edge of my piece of angle, and come down here and just drill my holes, and it worked out really well. I was able to put it right in place, because that was kind of an aggravating thing trying to deal with if you didn't have a way to create a template. Of course, this is kind of handy stuff I had. You probably won't have something like this laying around, but a piece of poster board, something like cardboard's too thick, doesn't work so well. It's not precise, but something like thin poster board, and something you can punch a hole in and get it to line up precisely, and then make your marks and drill your holes. So there's you another tip. Okay, up close view of how I did my spacing here, because I had to get it be on top of my hinge, and between the aluminum and the hinge I have 2 washers, and then on this end I put in 3. I put 3 over here to make up for the thickness of the hinge. So it's going to work out pretty good, I do believe. You can see again what I did down here. I got my spacing done. So I'm going to shove it up. Let's see if we can do this real quick. Okay, so I just got done pushing it all back in here. And you can see I can come back now and drill me some holes. I figure about 5 holes across there. I got me some nice screws with little caps that they'll snap over and make it look good. I paint these black. And do the same down here. I really like how it's just got such a flush look to it. Really has lined up well. It's going to look really good when I get all that done. Get the doors back on it. So it wasn't really no problem at all. Like I said, most time I spent getting these things drilled exactly right. Just take it all back apart and do some painting, and this will be looking good. Okay, next phase is to hook up my Xantrex Pro Watt with this thing called a switcher, maybe. I guess that's what it's called. AC switcher. Anyway, how it works is, so when I'm plugged up to shore power at a campground or running on generator, if I unplug from shore power or shut off the generator, either one, it will instantly flip over to battery power. I don't have to flip switches, think about anything, turn on anything. It just automatically for me. So it's just got 3 wires we have to hook up. So you see here, this is our utility power, which that'll go right in here to the receptacle, 120 volts. Okay, then this wire is AC load, so that'll go to the refrigerator. There's a cord. I gotta put ends on them because they don't have ends with them, so I gotta do that. And then this cord will go to the inverter itself, my 1000 watt Xantrex inverter. So that way, as soon as I unplug from shore power, it'll instantly connect to the inverter, and the refrigerator just keep running. That'd be pretty sweet. And also, like, I've only got a 1000 watt inverter, and for years that's been working fine for us, because I'm gonna run TVs, computers, anything I need. But I have I've got in the box still a 2000 watt Xantrex inverter, so I'm going to install it here shortly too. So the main reason I figured a 1000 watt would probably still get me by, because remember, the refrigerator only pulls 75 watts when running. The maximum wattage, I believe, is 140 when it goes into defrost mode. But with a 2000 watt inverter, my main reason for getting it is occasionally I like to fire up the microwave oven. Maybe we're boondocking, it's late at night, I don't want to wake up Sweet Pea at 2 o'clock in the morning. Maybe I want some oatmeal warmed up, so I can fire up the microwave and run it off the battery instead of firing up the generator just for a few minutes to do that. So that is my plan. And I've also got an older video, really old, from 8 or 9 years ago. I installed 2 of these because you know we don't, like I said, we have an individual inverter and an individual converter. I don't have one of those real expensive, like 3,000 watt, does everything in your RV setup. And personally, I kind of like having the 2 separate ones, because if one fails, I can quickly go out and get one and get myself back in business. Where those whole house ones, if one fails, I've lost everything. I've lost my charger, I've lost my inverter. So if I was to lose an inverter, I could quickly run to Harbor Freight, grab another one, get myself back on the road. Same way with the charger, the converter. If that thing was to fail in a pinch, I can run out and go get me just a real good battery charger to keep the 12 volts on the house side charged up. So that's my thinking anyway. So let me get some cords, some ends, and get to wiring this up, because I got to figure out a way to get power from down here in my batteries up in here into the refrigerator compartment. Oh, while I'm thinking about it, I told you I already have 2 of those Xantrex switchers, and I got them installed in behind this panel, and they power 2 separate circuits for me. So I've got them powering the circuits that control the TV, the living room TV, and the bedroom TV, and the bedroom circuit. And then also it powers another circuit that controls everything on this wall back here. These circuits in this circuit that covers all my laptops and stuff. So that pretty much takes care of about everything we need when we're boondocking. So that's, thought I'd point that out, and also point out the mess. Yeah, projects, it gets to be messy sometimes, but that's part of the fun. Well, sometimes you just get lucky. I got lucky just now. Remember I was talking about I had to somehow get a wire from the batteries from my inverter up into my refrigerator box, and I got to remember, there's a drain hose. So I got to look, and I took that drain hose and just shoved that wire right down through it. And what you know it, the drain hose passes right through here. So I just had to cut it. So right there, and I can just take that and wire it right into my inverter back there, and I will have power to the fridge. How easy is that? Alright, as you can see, I've got my ends on here. Both of them put on, and double check my polarity. Anytime you put a new end on a cord, double check your polarity. Make sure you got a good ground, no loose neutrals, and that crazy stuff. That makes for bad days. So double check your work. So I've done that. So now I got to do is tie this cord into my inverter down below, and we'll give this a test run. Alright, everything's wired up. We're ready for a test. So we got 120 volts here. I unplugged up to shore power, and we're going to see if this will operate off the inverter. So let's go in here. Let's see. Let's turn on the light. We see the light is on. Let's turn on the compressor. Okay. Fridge is on. Let me show you what happens here. So right down here is my refrigerator breaker. So I'm going to turn that off. You'll hear it click. And the moment I turn it off, you'll watch that relay will engage and flip it over to the inverter. You may have heard that click. Okay, so now we're running on inverter. Okay, next little project, let's mount this ProWatt switch here. And what I'm going to do, I'm going to mount it with some fancy Velcro. And I've already marked the place where I want it up inside there. See my little mark? So that's when I'm going to put the Velcro, and that way this will be positioned sort of up in here like this, out of the way. Won't give me no trouble. My wires be nice and tidy. So let's get that done. Well, I like the Velcro. That's worked out really well. I think you can see it up in there if I can get the camera right. There it is. And my wires all kind of tidy. Well, you know me, my curiosity. I have to see in behind this panel to see how this little refrigerator works. So I got the screws out, fixing to take it apart and show you. But first of all, I want to explain to you the airflow of these little refrigerators. So we're drawing air in at these bottom vents. They're being pulled in. You feel a lot of cold air blowing out the top. You also will have air blowing out the bottom into the refrigerator compartment. And this right here is not a thermostat. It's just a damper that opens and closes. It allows more or less air to go down into the refrigerator. So you can kind of fine tune between the freezer and the fridge. So that's, sometimes you can mess up. You say, I want max freezing in the freezer. Pull it to max. I'll show you what happens here. So if you go max, let's look down in there. So you go max, you've nearly shut that off completely. There's just a little bitty door left open. And it ain't focusing, but it's just a little bitty door. So if you go max, you're keeping the bulk of the ice cold air in the freezer. So you might find, oh, the freezer's now 10 below zero, but now the refrigerator's up to 45 degrees. So same way if you go the other direction, let's take it to minimum. So if you go minimum, now look in there. Now you got a wide open shot. So now you got a whole truckload of air blowing down into the refrigerator, ice cold air blowing into the refrigerator section, very little in the freezer. So in that case, the freezer may start climbing to 10 or 15 degrees and your refrigerator will be 32. So that's kind of the balancing act. I'm just going to show you here our pieces parts in here, kind of how it works, because this is our evaporator, because I've got it running. You see these ice is already forming, getting it good and cold. Because another great thing about this is your heater coil right here. Every couple of days, whenever it senses it, I don't know what it's got a little circuit board. At some point in time, it senses and goes into defrost. Might have to do with this little thermostat right there. That could be part of its design. Some refrigerators are different. Some work on how many times you open and close the door, how long the light is on. They got all these kind of computer algorithms that tell the refrigerator when to go in and out of defrost. And sometimes there's actually usually you'll see two of these little devices in here. One is more like a thermostat. Another one is a safety device. I believe this is a safety device. So say for instance, it went into defrost mode, because this thing can get red hot, you get warm. If it goes into defrost mode and for whatever reason didn't come out of defrost mode, this could get so hot it could start melting. So there's a little device in there, safety thermostat. It'll pop and allow it to shut itself down before anything gets too hot. Okay, I just turned the refrigerator off, so that fan may be messing up the sound. So anyway, another neat little device I found interesting is, you might look in here and say, what's that little wire do? So let's pull it out and I'll show you what it does. All right. So that's that little wire. Well, it hooks on to your heating element, the defrost heating element. So what can happen over time is ice will form in the bottom of this tray and prevent the water from draining out when it goes into defrost mode. So someone smart figured out years ago to put a little wire around there, and you see the little, there it is, that little drain hole. All right, where are we at? There's the drain hole. That's what goes out to the back of the refrigerator. And so this little wire gets tucked right into that little hole. And then when it goes into defrost, this wire gets nice and warm. As it gets warm, it melts out the ice, so it allows it to flow down into the drain. And let me show you where it goes. So it goes on top of the compressor, and this little tube here fills up this little tray, and then the heat from the compressor allows it to evaporate. So it's pretty cool how that works. In fact, you can see a little bit where I just shut it off. It's already dripping. You can see water's forming down there, and it'll run its way right down to that tray and down into the back. Here she goes. But really sweet little refrigerator. I think this is going to work really good for us in the RV. One last thing, remember the only thermostat we have is in the refrigerator. So that's why it's kind of a balancing act for the refrigerator and the freezer to get the temperature just right. That's for that little slide door it has in there. All right, so now let's get on to something else. I think it's about time to drill my holes in my brackets to mount this securely. All right, we're into the home stretch now, drilling my holes, but I want it to look good and I want the spacing to look right. So my thinking, I come off from the edge 1.25 inches on each side. Then I want to find center. So then I took my tape measure and divided it, and I found out that center is 11 3/4 inches. So I got 11 3/4 that way on that edge. Come over this way. Also got 11 3/4. So I'm going to put that center screw in, so that'll be balanced. And then we'll come back with, then I'll measure the exact center of those two, put in 2 more screws. So I have a total of 5 on the top, 5 on the bottom. And I don't think it'll go nowhere. And I'm going to have these pretty little buttons here that they'll hide the screws when I'm done. After I paint that black, it's going to look slick. So that's my plan anyway. Okay, for those of you that's more detail oriented, what I'm doing here, first of all, I'm taking a 1/8 bit, piercing the aluminum, going through the wood. So it's pre-drilled. That's the correct size for the screws I'm using. And then I'm coming back with a 5/32, just a little bit larger, and only piercing the aluminum. So then a screw will pass through it and then tighten it up, tight against the wood. So that's what I'm doing. Okay, well, I've changed my mind. I think 6 is plenty because that thing is just as tight as a drum. It's not budging a bit. So I got 3 on top, 3 on the bottom. Now I just got to disassemble it, these metal plates, so I can spray paint them and then put them back together. And this will be project will almost be done. Then do a little testing. Well, you see my little mounting brackets I made, and I've just sprayed them flat black with this rustoleum rust reformer, just something I had laying around. But before I did it, I took some alcohol to it and a little Scotch-Brite, cleaned up the metal real good before I threw the paint to it, and it turned out pretty well. Don't see no bubbles, no problems with it. So let's go get that installed. And I'm really liking how my little brackets turned out. Those little aluminum angle, I sprayed it with that Rust-Oleum paint. Another trick I did, I painted at night, but then I took it and stuck it in the dashboard of the pickup truck because it got like 85 degrees today, and I know it's probably 150 degrees on the dashboard where the sun was cranking in. So it really cured it good, I think. And so this will be up like this here shortly. There we go. So I gotta get my washers and bolts out and get that set in there, and I'll show you that as I go along. Just trying to be careful not to scratch nothing. Look at there, about to scratch it. Oh Lord, there we go. Okay, so I'm just going to show you what I'm doing here at the bottom. Got my piece painted. You see I got me a stack of washers here. I've got those there to match the distance on this piece. Now, I had to get on the ground here. Focus. There you go. Yeah, can you see the washers right back in here? I had to put those washers in there so that when I tightened up the 2 bolts, where's the 2 bolts at? There they are. See those 2 bolts? So if I didn't do that and I tightened up those bolts, it would bend that aluminum angle, the metal, because it's kind of soft. But because I got those stack of washers in there, I can really put the torque on it, and it's going to compress it good and tight and not distort the metal bracket. So at this point, before I put the refrigerator in, I got to get the doors back on and adjust my hinges, because once I push it in and mount it, I won't be able to adjust the hinges. So I got to get that done, and then I'll get up and I'll do the freezer door. That's what I'm doing next. I forgot to tell you something. The original screws in this thing was these little 6mm, maybe very short, 1/2 inch or so. So I got these long ones. These are 6mm, but 25mm in length. So that gives me the spacing I need to get up in there and get a really good tight anchor. And then on the upper screws up there, I went with a 20mm length, a 6x20. So just FYI. This may be overkill, but I noticed these pins, pivot pins, had no grease on them. So I put a little dab of grease on each one before I put the doors back on. So give those little plastic parts, plastic bushings, a little bit longer life. Alright, going to show you one last view before I push this in and tighten it up. See what I've got done. Got that bracket on there. And down here at the bottom. So I'm going to push that in there, put my screws in it, and it'll be anchored and won't go nowhere, I don't believe. Oh, and here's another tip. Be sure to pre-drill your holes, because if you don't, you risk splitting the wood. So put those little screws in there with the caps, and that's really going to look nice. Just got one more screw to go and pop those caps on. We'll see what it looks like. So what do you think? Does it look pretty nice? Looks like it came from the factory just about. These little button caps are great. These little things here. Get a whole bag of them for a few dollars. Tailpipe those screws. Because I also debated about maybe putting some like stainless steel button head screws. It's always a possibility. I can always change my mind later. But look how big that freezer is compared to the old Norcold. Good gravy. That is going to be so nice. So much space. And it's rock solid. It ain't going nowhere. I like it. I like it. Now we're about ready to turn this on. Finish putting the shelves in there, and we'll do some testing and see how it runs. I like it. I like it. Okay, let's talk about summertime versus wintertime use of a residential refrigerator in your RV. I've been surprised. I watched a few videos of other people installing these little small refrigerators in an RV, and I noticed they seal the box up completely. They take the vent that's up on the roof, they seal it off completely, plus they seal this off completely, and then they shove the refrigerator in this tiny little box with no venting. I said, well, what are you thinking? I mean, this refrigerator plainly tells you in the manual, this refrigerator, you need 1-inch clearance on each side, which we got right here. And you also need 2 inches on the top, which I got way more than that. And because if you notice, there are no condenser coils. Like on most refrigerators, you see condenser coils either on the back or on the very bottom. The condenser coils are in the against the sheet metal on both sides. That's where you put your hand on it, you'll feel it. It'll be warm. So with this design, I'll lift everything open. So during the summertime, the heat will just come, the cool air will come up through here. There's the chimney effect, take the heat right out through the roof. But I got to think about, okay, wintertime, when there are occasions when we do camp and it's cold, I need to figure out a way to keep that ice cold air out from right into the refrigerator. So I think I got it figured out. This little thing here. I just got me some blue foam. I don't know, was that 3/4 inch? Has a good insulating value. Painted it black because I didn't want to see blue looking through that vent or anything. I like the black idea better. And I just painted it with some acrylic latex paint I had laying around. You see I put the little button on the back, a little short bungee cord. And let's see if I can do this one-handedly. I'll show you how this works. Get it turned around. It's like this. All right. So say it's now wintertime. We're having a cold snap. It's going to get down in the teens. So I'll just slide this up here. There it goes. All right. Ta-da! Let's see, now I can pull that, and that keeps it good and tight. See how it seals up against it? It keeps the cold air out. I don't know if I can do this. Well, you get the idea. I'll have to stick this up through here like that. Let me get 2 hands. I can get it fastened. I'll show you exactly how it works here. Okay, so I got this in place. I got the foam in there. So I got this bungee cord. I just give it a pull. You see my little hook comes in right there. There's the hook. I get it. Let go. Now it's good and tight. I just tuck that cord up in there. Ta-da! I'll lock this back. And now it will be insulated, and no cold air can come up through that vent and suck my heat out. So that's my cold weather solution. Anyway, that's what I came up with. So one more little thing I had to do. Let me show you what I did. I think it's pretty cool. I think I continue to do this one hand. So I can come down here, pull it, get my unhook my hook, let go. That comes off. All right. But now I got to store this somewhere. I thought, well, how am I going to do that? So I made this little piece. This lifts up and sits right there on that little ledge. And let me show you what I made that of. Because you see, I got all kinds of junk sitting around. I just took a piece of this material here and cut it and bent it. This isn't made for metal ductwork. It locks it together. And so when I get into projects like this, I just grab whatever I got handy to come up with something. So that worked out really well because I was able to slide it over the back piece of this plastic tray, because that's what catches our water when it goes into defrost mode. And then the heat from the compressor allows it to evaporate. So I can just park that right there, and that way the air can still circulate and go up with the chimney effect it's not getting in the way and it's not dropping down here near the heat of the compressor. So I got that. Well, it looks like it's time to plug off this old propane line that we're not going to be using anymore. I did crawl under the RV with the idea of maybe removing the propane line from the main gas line and plugging it off down there, but the way it was positioned close to the frame and between the storage box, it'd been near impossible to get loose. So I'm just going to do it up here. I want to point out something is, because I went to Lowe's, let me see, let me get you the part number, it might help you. All right, here you go. There's a Lowe's item, little this thing called, there's somewhere, 3/8. Yeah, there it is, 3/8 diameter threaded adapter plug fitting. And that's what she is. So anyway, that's what I got today. And of course, all it does is fit right on here. Come on, camera, put you in the right spot. You tighten that up, and we got hopefully we'll have a good seal. Now, I'm gonna do something different. What I'd recommend for you at home, because remember how this seal works, compression fitting. The nut is very hard. This fitting is very hard material. The copper line itself is relatively soft. So it compresses and seals against the surface. And that's one thing you want to look at. So you want to make sure it's nice and smooth, focus, there we go. That it's not been dropped on the concrete and got a big gash knocked in it, because you want to get a good seal. And also, if I was you at home, I'd put a drop of oil on the threads just to aid in the torque. So it'll torque up a little bit better. No need to put any thread tape or anything like that, or pipe dope, because the threads really do nothing. The seal all takes place on this taper. But I've got something a little bit different, because I've been monkeying around with HVAC, and I've got some tools where I've been using, working on air conditioning and refrigeration and stuff. This is called Nylog, and it's really good for Schrader valves, compression fittings. And so for me, I'm going to put that right on the surface here and on the threads. And then after I put that on there, and I got my line wrench right here ready to go, I'm going to get it good and snug, and then I'm going to follow up with another product here. This is a leak detector. Of course, you're not going to have this stuff sitting around, but you can just use take you some Dawn soap, mix it up in a bowl, and just brush it on there real good and look for any bubbles. So that's all there is to it. Let's see if we can get this on here. There we go. So I'll use that. I'll smear that around. You get the ideal. I'll put it down on the threads here. I'll pop this together, and then we'll check for leaks. So let me get two hands on this project. Oh, and I would recommend putting a set of line wrenches in your RV to travel with, because I use them quite a bit. It seems like when I'm getting into things and you need to take a fuel line loose or anything like that, line wrenches do come in handy. So toss them. Just you can get you a cheap set. Pop it into a toolbox. All right, so I got it torqued up. Now I'm going to spray some my leak detector on there, and we'll let it sit for a while and see what happens. Another tip, while I'm thinking about it, I just turned this gas valve on. With these valves, I'm assuming everybody knows this, but you may not. Open the valve all the way up till it stops, till it seats. That way you get a good seal. If you had it kind of in between, you possibly risk a leak. So make sure any valve like this should be all the way open or all the way closed, not in between. So I'll squirt some more stuff on here. Where we at? There we go. I'll let that sit. If I don't see any bubbles, then I'll know we'll be in good shape. All right, so while I was waiting for my bubbles to appear, and I don't see any yet, I wanted to point out, make sure your wires are all tucked back out of the way, because you've got some really sharp pieces of metal back here. You want to make sure everything's fixed. So I got a screw here on that my charging cables from the solar panels, so they can't come loose and nothing get over here and rub in the wrong spot. So I think I got everything tightened up good, and nothing's going to be getting in the way of any moving parts or any vibration. Alrighty, let's go on to something else now. Okay, now it's time for a stress test, just to show you the 1000-watt inverter can usually do. Well, we've been running a 1000-watt inverter for years, and it works fine for us. But I'm going to stress it out, see how it does. So, refrigerator's running, because the doors are wide open. You can tell that. I got the most lights on we'll normally have when we're boondocking. Living room lights, kitchen lights on. I've also got the surround sound system on. TV is on. Even got my sub turned on down here. So that's about the max power we'd be pulling out of that. And normally I'd be sitting here, I'd have my laptop on, Sherry'd have her laptop going, which that wouldn't be much at all. But I'm going to stress it because I'm going to add like another 700 watts. I'm going to turn on this ceramic heater. So that'll really stress the system. Okay, so now you can see what we're pulling wattage wise. See, we're about to pull out, taking it up to about 1,000 watts. There it is, over 1,000 watts we're pulling out of it right now. And of course you can see down here, yeah, I hear the fan kicking on. My yeah, you hear it? She's hollering because it's peaking over 1,000 watts. But of course, you never have a ceramic heater running. Let's turn that off, see what our wattage drops down to. Okay. So with the refrigerator's doors wide open, lights on, it may take a minute for it to settle down. Okay, I gave it a couple minutes to calm down. So right now we're pulling out 352 watts. And you know, that's with TVs and stuff, refrigerators running. So that's not bad at all, I don't think. That would be like our normal late night boondocking with the lights on, TV on, minus the laptops, which that's not going to pull much. So I think this is going to work out really sweet for us. I'm going to do some more tests. I don't know what. Let's test something else. Okay, I thought something else to test or measure. I was wanting to figure out how much weight I gained or lost by doing this swap, getting rid of the Norcold refrigerator and going with the residential fridge. So I put me a scale over here and a scale over here. They both come in about 73 pounds. So together I got 146 pounds. So I got the refrigerator and I stuck the metal plates, the stuff I took out of it, out of the RV. So then let's go look at our specs. Okay, so according to the manual, the new fridge come in at 112 pounds. So it's lighter to begin with. So I was able to shed 34 pounds out of the RV. Of course, it's probably going to be offsetted because now we got more space. We're just going to pack 34 pounds more food. I don't know. Or I can load another tool in here. So I like that. That's another benefit. We're shedding pounds, shedding weight. That's always a good thing in an RV. Okay, updated video right now. We're pulling out the battery bank. Only thing I have on really is the refrigerator. I've got the lights and stuff off. There's other, I don't know, there's other draws somewhere evidently. But current wattage I'm pulling out of it through the inverter is 82 watts. If you remember the video I made before where I did a test on this when the refrigerator was in the house and I had a stable temperature sitting there, you know, like 75 degrees. But I had a 100-foot extension cord running from the RV to the house, pulling off the inverter, and it was consistently 75 watts, probably due to the fact that it's such a long extension cord. But still, that's very low wattage. And the temperatures we're dealing with in here is, I'll turn on the lights and we say, here we go. So we're sitting at 84 degrees. So it's a pretty warm day. Refrigerator's working pretty good. And so I think my next test, right now my battery bank is at 71%. I'm gonna plug it up to shore power, take the batteries up to 100%, and then I'll let it run for 24 hours in the RV with its final setup here, and we'll just see what kind of wattage or how much it pulls the battery bank down over a 24-hour period. I think that'll be some interesting stuff to find out. Okay, so while my battery bank is getting charged up, I thought I'd show you some temperatures because it's pretty warm in here. Like I showed, it's 84 degrees, which is pretty right. The wall temperature is 83. It's all we got is just that. There's no insulation, just that paneling. So we're sitting at 90 degrees. I can barely feel just a little bit of heat because remember our heat comes off the side of the refrigerator. There are no external condenser coils. And then on the other panel over here, about the same way. Yep, 90 degrees. Let's go up top. 91. That makes sense. A little bit warmer down here. 87. So that is really good numbers. Tickled with that. Let's try it inside the cabinet. First I'll show the compressor. Yeah, compressor's 138 degrees. You can tell it's working. Let's go inside the cabinet here. 84. Let's shoot up inside here. Go up kind of high with it. 85 degrees. So yeah, that's the chimney effect here is working really well about pulling the heat up. So I don't see any need whatsoever to have any fans. So I believe this is going to work out dandy. So I'll let that charge up and we'll do our 24-hour test. I just discovered something, and this is a warning. I think I mentioned this before, but now I can prove it to you. The Freon lines, Freon or refrigerant lines, run along these edges here, and it keeps frost from building up around the gasket. And to prove that, because I touched it, it's really warm. You can see here, it's 107 degrees. That's 97. So I just noticed put my hand on here and I felt that real warm temperature, and I thought, man, because I know what people put in these RVs, they think, well, I'll just screw me a bracket here and up to there. Well, if you put a very long screw, you're going to punch a hole in your refrigerant line, and that's just going to destroy the refrigerator. So word of caution. That's why I utilized the mounting screws that were already here, because I was afraid that could be a possibility. But so what's the temperature on that one? Yeah, 105 degrees right on that metal right there. Anyway, there's your another tip. Don't punch a hole in your refrigerant lines. Okay, time for a test. It is 12:30 a.m. Batteries are 100% charged. We'll grab here. We're going to unplug shore power. And let me show you here, so you know. You can see right here, this is the inverter side. Pulling 0 watts. This actually may not come on if it's satisfied. It probably won't. Let's see. Okay. And yeah, okay, it's not pulling anything, but we do have voltage. All right. Because it's not pulling any watts because it's not calling. So we'll just let that sit here till tomorrow, and we'll see how much it pulls down. Well, it's the next day, and actually I went long. It's 14 hours. So 14 hours is a good test. Just to give you an idea, 14 hours in the building, no sunlight, only pulled with the refrigerator running. I pulled it down to 82%. Now keep in mind I have 3 battle-born batteries. So I have a 300 amp hour source of power. So out of 300 amp hours, I'm down to 82%. And let's turn on some light. Let's see what the fridge is. Look at there, 5 below 0. Is that sweet? What's your fridge sitting at? I don't have a thermometer in there. I thought it did. All right, but yeah, it does a great job. Pretty cool. I'm liking it more every day. Okay, I'm trying to wrap up my RV refrigerator install, and I thought about a problem that could happen, which you get your groceries in there and you're driving down the road in the RV that shifts, bumps the door, and it opens up and everything pours to the floor. So I know there's devices you can buy online. You can stick on here with some 3M tape and snap it like, kid locks. But I didn't want something on there permanent in a way. I wanted something I could just put on and off. And when we go to travel, put it on there, do its job. We get to our destination, we can quickly unhook it and get it out of the way. So I come up with a cool little device, and I'll show you. Oh, then when we're not using it, I can quickly store it out of the way. So out of sight, out of mind. So here we go. Let's see if I can do this with one hand. The components I use, pretty simple stuff. I just found it in my junk box here. This is an eye hook. Actually, it had this piece. It also had this piece on it. I cut that off. It's stainless steel. It's really strong, so it won't bend. So with that there, I can take this piece I made and just hook into it. Let me change hands here with the camera. Try to do this with one hand. So with this, let's get the camera in a close up. So I just hook this in like that. Right now I gotta get the refrigerator door over here to me. And of course you just see it's made out of a bungee cord material. This here is made out of 1/2-inch cutting board plastic material. And that little part there is something you use in electrical wiring when you go to twist your grounds together and you crimp them. That's what that little copper piece is. I just put that on and squeezed it so it would be like a locking device, so I could adjust the tension easily. So now all I got to do is just give this a tug, close the door, come right here and let go. Ta-da! Now the refrigerator is locked. It's not going to open up. We'll go down the road. If we hit something, it's going to stay put. And we get, if we need to get to the destination or just need to get a pop, we just take this out, open the door, grab a pop, put it right back. When we finally get to our destination, we get set up in camp. We just take it off completely, give it a tug, and put it back in storage. There you go. Easy peasy. Oh, about broke a leg. Anyways, make yours today. Okay, let's talk dimensions. So my old Norcold that I took out was 7.5 cubic feet. Norcold, the higher, and I found out that's how you pronounce it, is higher. I called their toll-free number and listened to their voicemail. That's how they pronounce it, because I didn't know how to say it exactly. So for the new higher refrigerator, it's got 9.8 cubic feet. And you can see the dimensions here, because 18 in the freezer is about the same, 14 feet. The biggest thing is on the depth. So we got like 14.25 deeper, a lot taller. So you can pack all kinds of ice cream in there. Okay, but then with the fridge is a huge difference. So in the Norcold, you got 18 inches, we're going 19.5. The Norcold is a hair bit taller, but the depth is hardly nothing. See, the Norcold only got 13 inches deep, where the higher refrigerator is 20.5. And a really good visual example of that is this is your whole thing of pop here. Let's go take it over here to the Norcold just to show you a difference. Try putting this in your Norcold. See, there's just no way. So that gives you a good idea of how much more space that this higher refrigerator will give you. Given that 9.8 cubic feet. So I'm really liking that. So it gives you a better idea of how much space you can gain by upgrading your refrigerator. Okay. And if you're wondering about noise, there is none. It's running right now. I can barely tell. If I get real close to the wall, I can hear the hum. Of course, if you step outside, get close to it, you can hear the compressor. So it makes no noise whatsoever. So you never know what's even on. Oh, I know, I was going to show you. I found something interesting when I was looking at this a while ago. The specs on this. I was looking at this for even, here we go. So think about it, when the Norcold refrigerator is running, if you're plugged up to shore power and you have to pay for your electricity, it's pulling 300 watts as you're there whenever it's cycled on. And even when you're in like boondocking mode, the wattage it pulls on the 12 volt side is 14 watts. So that kind of surprising, especially the wattage. It pulls 14 watts just, I guess, pretty much all the time with the circuit board and stuff. So I found that an interesting finding. But, that 300 watts adds up compared to about 80 watts is we're averaging, is what I'm seeing on this meter, on the new fridge. Okay, there's another thing I didn't like. I just came up with a solution for it. Because I got my brackets here, they worked out really well where they're mounted securely, but I had this little gap here. And of course that gap with the chimney effect, it could draw, create a draft through this gap. And I guess possibility of bugs could come in too, because you got this is always open right here. But the biggest thing is that chimney effect. You could be drawing air and stuff through there. And I thought, well, I need a way to seal it up, but I want it to look good. So what I came up with, I thought, what would MacGyver do? I thought, well, MacGyver would use something he had laying around. So I went to looking at my junk pile and I found some vacuum hose. So let me show you what this looks like. I'm gonna get 2 hands, shove it in there, and I'll show you before and after. And now there's the after. Does that look good? Sealed it up completely. I just gotta get some more of it because I ran short. But at least I got a solution because I got the same gap here at the bottom that I need to take care of. So anyway, that's my solution for that problem. Now on to the next. Well, I don't know, I'm about to wrap this up, it looks like. Okay, let's wrap up this higher refrigerator install. So just go over the components besides, buying the refrigerator. What else did I have to buy? Well, I didn't have to, but I did buy this auto transfer switch. It automatically would transfer between the inverter and shore power or generator power. I like that, but it's not necessary, but I put that in. I had to buy this little 3/8 threaded adapter plug to plug off the propane line. Of course, remember I tested it and made sure we had no leaks. I bought some longer bolts to mount these brackets with, and gave me access to those strong mounting bolts in the corner. Because remember, I warned, be careful, don't be drilling no holes, because you got Freon lines running in behind here. You punch a hole in a Freon line, it's going to ruin your day. And I got these little caps on Amazon. I can't remember what these things are called, but they're really nice because it hides your screws, makes for a nice clean look. And the only thing else I got was this piece of angle, 1/16 by 1 1/2 at Lowe's. There's the item number 11357. So very few parts I had to buy to put this together, and I did most of it myself. It does help if as far as getting it hoisted up and taken out. 2 people But if you're creative, one person could do it. But let's step back and see how it looks from afar. So we look back here. It looks really good because we got the black microwave and stove, so all that matches. And from this angle. And let's go the other way. So I like nice clean look of it all. I think it turned out sweet. Remember, when you do your install, you know, make sure your doors can open all the way. So if they open all the way up, you can easily slide these out. And the doors are reversible. You can put them on either hinge. So it's going to be great to have a super ice cold ice cream. Sure turned out well. And if you've made it to the end of this video, well, you deserve a gold star, because I know I've talked a lot on this one. But anyway, thanks again for watching, and have a blessed day. See you, bye.